Supplemental math videos from Circle Christian School. Hooray, hooray! Let's take a trip down Main Street, USA, because parallel lines make cool angles. Either the angles are congruent or they end up being supplementary, equaling 180 degrees. After all, 180 degrees and being congruent is probably the coolest things you could ever be in geometry. Let's take a look at some of the properties for the congruent for parallel lines. The lines have a transversal, and I always like to highlight my transversal, so you should too. We'll call it T, and we are basically given that line L here is parallel to line M, and we have the little red tick marks that tell us that the two lines are parallel and equidistant from each other. That makes 8 separate angles here. The first thing that we remember from our properties is the vertical angles, and that vertical angles are all congruent. I'm going to give it a little bit of symbolism here so I can shorten it up a little bit. But vertical angles are all congruent, so we can say that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Likewise, down below, since there's an equidistance thing happening here, angle 5 is congruent to angle 8, and angle 6 is congruent to angle 7. So vertical angles are the first property that happens with parallel lines here. The second property that happens with the parallel lines is that we'll remember that we have linear pairs. Linear pairs are a pair of angles that are shared on a line and equal 180 degrees. So angle 1 plus angle 2 equals 180 degrees. Angle 2 plus angle 4 equals 180 degrees. They're a linear pair. Angle 4 plus angle 3 equals 180 degrees. I think you get the idea here. Likewise, angle 3 plus angle 1 equals 180 degrees also. And we can do the same thing down below here with 5, 6, 7, and 8. So the two things that we have, because we've already studied these and had the property that when we have two lines that intersect, we end up with vertical angles and we have linear pairs. Okay, there's a couple other fun little properties that happen with these angles. So let me erase what we got here. And I want to go a little bit larger here. That because of our vertical angles here, that we've got these congruencies that are happening, and I'm just going to kind of change the colors up a little bit so you can see them a little bit better. And this is using those vertical angles, that there are some other cool properties that happen with parallel lines in the relationship within the angles. All right, I liken the next properties here pretty much to driving down Main Street. So I got my cool little Volkswagen Bug, and he's driving down Main Street here, USA. My little transversal. And each one of the intersections here are pretty much where the stoplight would be at. It's like an intersection in town there. So we have two intersections here because we have two parallel lines, line L and line M. And I think of things like angle 1, 2, 3, and 4 as being the four corners of the street. Angle 1 being the first corner at the top on the left-hand side. Angle 2, the top right-hand side. Angle 3, bottom left-hand side. Angle 4, bottom right-hand side. And what happens here, and if you notice that because of what happened with the vertical angles, that as we come to the street corners, that the first one up here at angle 1 is actually the same size that we have here at angle 5. So as we come to the next intersection, notice that the corner of the street has a relationship here, and we call those corresponding corners, or what we would call in geometry angles. They're corresponding angles that the top left, angle number 1, is congruent to the next intersection, top left, angle number 5. So angle 1 is congruent to angle 5. And likewise, angle 3 is congruent to angle 7. Has a direct relationship as if it was street corners going through the intersection there. Angle 2 is congruent to angle 6, and angle 4 is congruent to angle 8. Corresponding angles. The next thing is two other properties that happen in a congruency. The first one being alternating interior angles, alternating, jumping back and forth across the street, interior, inside the parallel lines, angles. So I'm going to move right here inside this area, inside the parallel lines, interior, alternating, I'm jumping across the street. So for instance, if I was to kind of like jaywalk across the street here, because I'm not at a crosswalk, notice that angle 5 is congruent to angle 4. And going across the street the other way, angle 8 is congruent, not angle 8, my bad. White out. He's not on the inside. Angle 6 is. That angle 6 is congruent to angle 3. So if we jump across the street here, alternate, on the inside interior of the parallel lines, the angles are congruent also. Another cool property that happens with the angles are alternating exterior angles. Alternating, jumping, exterior, outside, and maybe you're already beginning to see it, angles are on the, let's do these in yellow, are on the outside of the parallel lines. On the outside. So angle 8, who's on the outside, is congruent to angle 1, and angle 7 is congruent to angle 2. Now I call these my Spidey angles because you can't jaywalk across two different intersections. You actually have to swing from building to building using your Spidey webs to find the congruent ones. So we have 4 vertical properties. That's vertical properties, congruency properties, vertical angles, corresponding angles, alternating exterior angles, and alternating interior angles. Now the last one we're going to look at is, and I'm just going to do a little bit of redrawing of my lines here, my angle congruencies. Here's the blues. There's the blues. Very good. That a reminder that we have linear pairs that we already talked about, linear pairs that equal 180 degrees. But we also have another supplementary property happening. And supplementary means two angles that we add together to equal 180 degrees. Linear pairs have to have that line connecting them. But if you take the measurement of angle 4 and add it to angle 6, they likewise will equal 180 degrees. And angle 3 added to angle 5 also equal 180 degrees. So they are supplementary. These are called consecutive angles. Consecutive angles, ones that follow each other one after another. All right, let's try this set of parallel lines. First thing, of course, is you draw a picture. Make sure you got some good labelings going on. We're given that line L is parallel to line M, so I'm going to give myself some little markers. And I always like to highlight my transversal in some sort of color just so I can see that everything's being worked upon the transversal. So the first thing I'm going to do is look at some of my geometry properties. And we know there are 6 things that allow us to work within the angles on parallel lines. So let's check out what is happening directly between the x's, because to work problems it's nice to have same variables. And you'll notice that they are on the same street corners, so they're corresponding angles. And corresponding angles are congruent to each other, so therefore that will allow us to be able to put the two problems congruent to each other. So we have a 6x plus the 96 equals the 10x plus the 80. Very good. Remember that now when we start to solve a linear equation, we're going to go through the 3 star steps. Start with the fence of equality. The next thing is to see if there's any distributing or combining of like terms, any simplifying. There is none, because we have an x, a number on one side of the fence, and an x and a number on the other side of the fence. So we can move off to step 2, isolate the variable, and I like working from right to left. Work it being a little more consistent, and you'll get rid of those silly mistakes. Since I want the x by itself, and step 2 is isolate the variable using the additive inverse, we're going to get rid of all the addition and subtraction. So I'm going to go minus 96 here. That's what's going to make them say goodbye, so long, farewell. And we're just going to do the work. So I get a 6x. These are gone. And we have a 10x minus the 16. Big number carries a sign. Next, you'll notice that on the right hand side we have too many things, and what we want to do is get a constant number by itself. I like my x's on the left, my constant numbers on the right, even if it involves integers. Don't be afraid of integers. They're just numbers. So the inverse says do the opposite, so we're going to take away 10, the 10x. X's from x's, numbers from numbers, and that's going to give us, and I again am ever going to do everything from left to right. The more consistent you become in doing these, the more consistent your answers will become. So we get a negative 4x equals, and the 10s go away, and negative 16. Step 3, isolate the variable using the multiplicative inverse. There is no more addition or subtraction. So now we're just going to divide by the negative 4. All right, dividing by the -4 leaves us with an x equals, I'm sorry, I just noticed I didn't have a 16 in there. Not really sure where all that went to, but it seemed to disappear. So x equals a +4. Signs first, math second, so we know x equals 4. Just nice to have somewhere. Alrighty. Let me erase and I'll rewrite that the x equals 4. And we're going to work on trying to find y now. Okay, so I'm going to find out what's happening between the angles where my y's are at here. And if you notice here that the bottom one here is an acute angle, while the top angle is a obtuse angle. Sorry, my crazy phone seems to be going ultra crazy all at one time here. And since one's acute and one's obtuse, we know they're not congruent to each other, so it's got to be one of the other two, either a linear pair or the consecutive angles. Well, they're not a linear pair because they're not on a line, but I can see that they are one after another, and you'll remember that consecutive angles equal 180 degrees. So my setup here is going to be to add them together, plus the 45 here, and it all equals 180 degrees. Okay, going to start with that little fence of equality. And we're going to combine some like terms. Y's with y's, 12 y's, 3 y's, 15 y's all together. And we have some digit numbers. We're going to add digits together. So we have 60 and 45 equals a positive 105. Oops. Oh, all my colors are changing. And I really just wanted purple anyway. Very good. And so now that's going to bring me into step 2. First we combine some like terms. Step 2, isolate the variable using the additive inverse. Want to get rid of all addition and subtraction. So I'm going to minus the 105 here. That's going to leave us with a 15y. Little guys go away. Equals 180 take away 105 is 75 degrees. And so y divided by the 15 divided by the 15, y is going to equal a 5. Very good. So I know x equals 4 and y equals 5. So now we have to find angle 1 and angle 2. So we're going to have to look at the properties of what's happening in retrospect to different things here. I notice that angle 1 here is supplementary and a linear pair to what happened with my x. So if we put a 4 inside here and take 24 and add it to the 96, we'll see that this obtuse angle here is 120 degrees. And remembering my properties of a linear pair equal 180, we know that angle 1 equals 60 degrees. Very good. Well, if the top one up here next to angle 1 was 120 degrees, I can go down to the same street corner here and know that this is 120 degrees at this intersection, same street corners, corresponding angles, and that just allows me to go vertical over here, and this be 120 degrees also. And to tell you the truth, you should be able to find all the measurements of all the angles once you have discovered just one of these angles. Once you have discovered just one, you can actually identify the measure of all the angles using vertical angles and our corresponding angles that happen along parallel lines. Remember that. Parallel lines make very cool angles. And how could you go wrong in a day like that?